Okay, so today we're going to look at solving mathematical inequalities. We'll start off with some basic linear inequalities, which should go pretty quickly. Then in the latter part of the notes, we will be solving some polynomial inequalities and rational inequalities, which gets just a little more complicated. So just make sure you pay attention to the first example of the polynomial, and then the rest of them should be a little bit more clear from there. All right, so this first one is simply linear, so it's going back to your Algebra 1 roots. So you have to be careful and make sure you're distributing your negative sign correctly. So we'll have 3x minus 12 minus 4x minus 2 greater than 8x plus 7. Okay, so now we're going to be solving for x. So I need to gather my x's on one side and my constants on the other. So over here on the left, you can see that you can put your 3x minus your 4x and your negative 12x and your negative 2 together. So we're going to have a negative 1x minus 14 greater than 8x plus 7. I'm going to move my 8x over to the left and my negative 14 over to the right. So I get negative 9x greater than 21. Then you have to remember your rule here. When you multiply or divide both sides by a negative number, you have to flip your sign. So if I flip my sign, I'm going to get x less than negative 21/9. If I reduce that, I get x is less than negative 7/3. So there is the solution as an inequality. If you look at the directions, you need to write it as an interval and set notation. So interval notation is going to be all values of x less than negative 7/3. So that would be parentheses negative infinity to negative 7/3, not included. So that needs to be a parenthesis. Set notation, all values of x such that x is less than negative 7/3. So Algebra 1 review with interval notation and set notation. Okay, so this one looks a little bit simpler, not quite as many numbers. So I'm going to, again, gather my x's on the left and my constants on the right. So I would have a negative 5x less than or equal to negative 13. I always put the x's on the left, because that way my inequality symbol is being read correctly. So now again, I need to remember to flip my sign, so I get x greater than or equal to 13/5. Remember, you can always choose a value in the solution set and get back into the original problem to make sure your solution set is correct. Okay, so interval notation will be 13/5. And I'm including that endpoint because it's or equal to positive infinity. Or in set notation, all values of x such that x is greater than or equal to 13/5. Okay, again, Algebra 1 review. Okay, so now when we solve quadratics or rationals, for quadratics, or basically any polynomial, I need to set equal to 0 and factor. And when I factor the polynomial, I'm going to be determining the zeros. Or the x-intercepts, where the function is equal to 0. Okay, so the second thing you're going to need to do is we're going to set up what's called the sign chart. This really helps with more complicated polynomials. And this is also going to help you understand how to do these without using your calculator. And once we set up the sign chart, we're going to test the intervals between the zeros for positive and negative values. Okay, so if your inequality is greater than, then you're looking for positive values. And if your inequality is less than, you're going to be looking for negative values where it sits under the x-axis. For rationals, you need to determine the zeros in the numerator and denominator. Numerator and denominator. In your denominator, remember, those are going to be vertical asymptotes. So those are going to be restrictions. And in the numerator, there'll be actual zeros. Okay, so then, obviously, you may have to factor in order to do that. Then you set up a sign chart again and test intervals. Okay, so this will be new for those of you that are coming out of just Algebra 2. If you took college algebra before you took trig, then I have a feeling that Mr. Abundis taught this in college algebra, so this will be review for you. All right, so we are going to look at a pretty simple one, x squared minus 16x plus 60 less than 0. So this one, since this is less than, we're looking for negative values. And zeros not included. So if it was an or equal to, we would be able to include 0 in our solution set. All right, so this one factors to, I need to multiply to positive 60 and add to negative 16. That is going to be a 10 and a 6, and they both have to be negative. I don't spend a lot of time on factoring. Okay, so I've got it factored. So I have zeros at x equals 10 and x equals 6. So I'm going to set up my sign chart, and I'm going to go into detail on this one. After I get through this one, my detail will not be quite as precise. All right, so my zeros are at 6 and 10. Make sure you always put in order from smallest to least. Since this is less than 0, these zeros are not going to be included in my solution set. So I put open circles on those so I can remember that. Okay, so now I need to think of this being a number line, and I need to pick a value less than 6. So I'm going to pick 0 because that's pretty easy to use. So these are called my test points. A number between 6 and 10, let's pick 8. And then a number greater than 10, let's just go with 12. Okay, so now what I have to do, and eventually I'll just in my head because mental math is pretty easy. So what I do is I take that factor and I'm going to plug 0 in for x. So 0 minus 10 times 0 minus 6. So that is a negative value times a negative value. Negative times negative is positive. So in the interval from negative infinity to 6, this quadratic is sitting above the x-axis. All of those values up to 6 are going to be positive. So now I'm going to plug in 8. And again, this is the piece of the puzzle where I'm plugging these in, where eventually I'm just going to do this in my head. So 8 minus 10 is negative. 8 minus 6 is positive. Negative times positive is negative. So that's where that quadratic sits below the x-axis. And over here, I'm going to plug in 12. Oops, yeah, minus 6. So I get a positive times a positive, which is positive. So since I'm looking for values that are less than 0, I am looking for all of these numbers between 6 and 10. And for a quadratic, if you kind of think about back when you did your graphing a quadratic, this quadratic would have 2 zeros at 6 and 10, and it would open up because the coefficient of x squared is positive. So this quadratic would actually look like this. Think about this line being the x-axis. So it makes sense that the quadratic is negative or less than 0 between the values of 6 and 10. Okay, so writing that in intervals, or the solution in interval notation, we can't include the endpoints, smallest to largest. We're going to go 6 to 10. Or set notation, all values of x such that x is greater than 6 and less than 10. Remember, on this piece of the puzzle, your symbols should always point to the left for less than, and your numbers should go from smallest to largest. All right, so that was a pretty simple one because it was just a simple quadratic. Okay, so now this is actually the beginning of the next day, but I combined the 2 days into one. So this is technically a review because it's linear. So we can get through this one pretty quickly. We don't have to do a sign chart for this because it's a linear inequality. Okay, so I'm going to distribute my -2, so I get -4t minus 10 greater than 6t minus 24 plus 3t. So here I can put these together for 4t minus 10 greater than 9t minus 24. Gather your t's on one side and your constants on the other. So you get -5t greater than -14. Switch your sign again. T is less than 14 over 5. Now you could do a sign chart for this too, but there's no need. Your 0 is at 14/5, and you would have a interval to test on the left and the right of that value. Okay, so interval notation for this would be -infinity to 14/5, not including the endpoint. So parentheses, set notation, all values of x such that x is less than 14 over 5. Okay, so now let's do another more complicated one. Looks like we have 2 more examples. One's a polynomial and one will be rational. Okay, so this is a cubic function. So we need to do some factoring. So I'm going to pull out my greatest common factor x, minus 3x minus 14. Okay, so factoring 2x squared minus 3x minus 14. So we are in a pretty advanced math class, so I am not going through the factoring process. I'm also going to suggest that you learn how to factor these simple quadratics in your head. It's going to help you immensely on the ACT because it's much faster. Okay, so factoring in your head, if you must go off to the side and use that M method, please feel free to do so. Okay, so my 2 values at the beginning, well, I know I have to have a 2x and an x because that's the only thing I can multiply by to get 2x squared. So to get my -14, I have 1 and 14 or 2 and 7 to use. I usually start with ones that are closer together and I just do trial and error. So I know I need a -3 in the middle. and a negative 14. So one of those is going to have to be positive and one's going to have to be negative. Well, if I put the 7 here and the 2 here, that's going to give me 14x and 2x. That's not going to help me with 3x. So I go back to the drawing board and I switch my numbers. And lo and behold, that is going to help me. Now on the outside I have 4x, and on the inside I have 7x, and the difference there is 3. This one needs to be negative, this one needs to be positive. So there is trial and error factoring for you. Okay, so I have 3 zeros. X equals 0, 7 over 2, and negative 2. So I'm going to set up my sign chart. I have 3 zeros to worry about on this one. Make sure you put them in order from smallest to largest. 7 halves would be, I'm going to put it here. Nope, it needs to be the 0, sorry. And then 7 halves here. Okay, so for this polynomial, since it's or equal to, all of these endpoints are going to be included in my solution. All right. Okay, so now I need to find points in these intervals. So less than negative 2, I can use negative 3. Between 2 and 0, I can use negative 1. Between 0 and 3 over 2, I'm going to use a positive 1. And here I think I'm going to just use a 4. Okay, so now remember, these are your test points. So I'm going to be plugging these in this factor, and this factor, just like I did before. This time I'm not going to write them out for you. We're just going to calculate the positive, negative value in our head. Okay, so for this one, actually I'll go through and do these in color for you. So I'll do the x coordinate in purple. Okay, so if I put a negative 3 there, I have a negative number here, a positive number, and a positive number. Okay, so all I was doing there was substituting in to the value of x. Now I'm going to take those 4 numbers and I'm going to plug them into 2x minus 7. So negative 2 times negative 3, negative 6 minus 7, that's another negative value. If I put a negative 1 here, I'm going to get negative 2 minus 7, that's negative. If I put a positive 1 here, I'm still going to get a negative. If I put a 4 here, that's 8 minus 7, that's positive. Okay, so now I'm taking those 4 values and I'm plugging them into x plus 2. So negative 3 plus 2, that's going to be a negative value. Negative 1 plus 2, that's positive. 1 plus 2 is positive. And 4 plus 2 is positive. So then if I go back and I take negative times negative times negative, I get negative values in that interval. Here I get positive. Here I get negative. And here I get positive. So remember, I'm looking for greater than or equal to, so I need to look for my positive values. So I'm going to be looking here. And I'm going to be looking here. So there are your intervals. So my solution is negative 2 to 0, including the endpoints union. Negative 2 to 0, including the endpoints. And then again from right here, 7 halves to infinity. Interval notation is the easiest way to write this answer because you have so many endpoints. If you're asked to write it in set notation, then it would be x is between negative 2 and 0. And then again, x is greater than or equal to 7 halves. Okay, so when I did my positives and negatives, remember, I simply plugged it in, each of those values in my head, into each of the factors and determined if the value there would be a positive or a negative value. If you think about graphing a polynomial in behavior, we have our zeros. We also know, you learned how to do this in Algebra 2 and or college algebra. In behavior, for a cubic function, and a positive lead coefficient would be down on the left and up on the right. So it actually graph to be something like this, and you can do this with a polynomial. All of those zeros would be crossing zeros. You're looking at all values of x above the x-axis would be right here and right here. So if you remember your polynomial graphing, it's an easy way to do it that way. But when we get to this next one, which is rational, it's a little bit harder. Okay, so these notes are going to get a little bit longer, probably about 5 more minutes, so I apologize for that. Okay, so for this one, it's rational. So we're looking at positive values, not including 0. So I need to determine my 0, which comes from the numerator at x equals 0. And then down here, I need to determine the zeros of my denominator, which are going to be undefined vertical asymptotes. Factors to x and x, and I believe 60 would be a 15 and a 4. So those two numbers add to 19 and multiply to 60. So I have a 0 at x equals 0, and I have vertical asymptotes at x equals negative 15 and x equals negative 4. So here is the function that I'm going to be using to plug in my values to determine positive or negative. And this is going to be a fraction, so it'll be a little bit different. X plus 4. Okay, so I need to set up my sign chart table. I have 3 values to worry about. Smallest to largest, negative 15, negative 4, and 0. Okay, so when I'm doing rational, I go ahead and label this as a vertical asymptote, so that's never going to be included. This negative 4 is also a vertical asymptote, so that point will never be included. The 0 is a 0 of the function, but since my inequality is just greater than and not greater than or equal to, then that value is never going to be included either. Okay, so now I determine the values. I have a negative 16, less than negative 15. Somewhere in here, I'm going to choose negative 5. Here, I'm going to choose a negative 2. And down here, I'm just going to pick 1. Okay, so since this is rational, I'm going to put the fraction bar for my positive negative value chart when I plug in those numbers, my test points. Okay, so let's do the numerator first. So let's go through and plug in those test points in the numerator. So if I take 2 times negative 16, I get negative. 2 times negative 5 is negative. 2 times negative 2 is negative. 2 times 1 is positive. Okay, so now let's take and plug them into this piece of the denominator and determine positive or negative. So negative 16 plus 15 is negative. Negative 5 plus 15 is positive. Negative 2 is positive. And 1 is obviously positive. Those are denominator values. So then I'll use green, and I'm going to plug this into x plus 4. So negative 16 plus 4 is negative. Negative 5 plus 4 is negative. Negative 2 plus 4 is positive. 1 plus 4 is positive. And I can use my phenomenal mathematical abilities and use my rules for positive and negative. This would be a negative over a positive, which would be negative. This would be a negative over a negative, which would be positive. Remember, this is a rational function, so if you're going to sketch a graph, it's going to have asymptotes and all those good things. So this one's a little bit easier to use your sign chart. Negative over positive is going to be negative again. And then I've got positive over positive, which is positive. Since this was greater than, I'm looking for all of my positive solution set intervals. So this function would be greater than 0 between negative 15 and negative 4, and from 0 to infinity. So interval notation, none of this is included. Vertical asymptotes are never included. Zeros are only included if it's nor equal to, but this one was just greater than. So interval, negative 15 to negative 4. Union, 0 to infinity. Or all values of x such that x is between negative 15 and 4, negative 4. And x is greater than 0. All right, so we'll do a little bit more of this tomorrow. And if you're at home, I will make sure that when we do the next day in person, I'll work on this a little bit slower in case you're having trouble with the sign pattern chart. Have a great day.